Hello and welcome to this Modurol video. This is MT34 in our series of XK8 videos detailing how we converted our automatic Jaguar XK to manual. And in this video we're going to look at the detail of the slave cylinder as used in the S-type manual. Now the reason we're doing that is if you've been following our series of videos, using this slave cylinder and our pedal box, our master cylinder, we weren't getting the proper clutch release, and I couldn't understand why. So in order to do that, we're going to do a deep dive into this slave cylinder. So in order to do that, we're going to break the video down into several sections as per normal. First of all, we'll look at the part number of this and the alternative part numbers, the actual components of ours. I've got the old one. I've actually bought a new one because the thrust bearing didn't look very good, so I've broke the old one down. So we'll have a look at how the actual slave cylinder works. Then we'll look at the particular problems with bleeding this cylinder, then the actual technical specification of it and the resulting hydraulic ratios. Part numbers. The existing part number is XR832967, and it utilises 3 M6x20 bolts, part number C2Z1859, and they need to be tightened to 9 Newton meters. Replacement parts cost about £84 off eBay. If you look at the S&G Barrett website, it actually calls for the XR82820 part number, which is actually quite different and quite a lot more expensive. When you compare the two part numbers, they're quite different looking and there's a lot of physical differences. There are different feed pipes, so they aren't strictly interchangeable. On the XR82820, there's actually an additional base which actually packs the whole slave cylinder upwards. Critically, there's no bleed pipe on the XR83267, but there is on the XR82820, which makes the actual slave cylinder slightly easier to bleed. Components then. Okay then, so we'll have a look at the component parts. So here we have the fully assembled new one. As you can see, it's actually got a spring return. So if we take apart the old one, you can see the spring. There's actually a spring and a retaining sort of cup at the bottom that sits like that. Can go like that, okay. Then you've got your rubber gaiter, which sort of sits in a ring around here, and this is the thrust bearing, obviously, which spins okay. It actually was quite rusty when I first opened it up, but it looks serviceable now, but you can hear it, so that's obviously worn out. And then this is the actual cylinder, or sorry, piston. This is the piston with the seal, and that drops in over the top of there into the cylinder itself, and then that acts on the thrust bearing. So as you put hydraulic fluid in, it comes through a hole at the back. I don't know if you can just see that at the back there. That's where the fluid comes in. It pushes against this seal, pushes forward, and then contacts the thrust bearing to push that forward, and the whole thing, as I say, is sprung loaded. Now, how did I get this apart? Well, if you see at the front there's actually a small steel pressing that sort of is crimped over at the end. So I think the idea is this is supposed to hold that crimped metal pressing there. Is supposed to hold the the thrust bearing on, as you can see here. It's actually quite flat at the top and it holds it on. But I was a bit over enthusiastic pumping the pedal, and actually it's very easy because of the hydraulic leverage, etc., the hydraulic force, to overcome and deform this metal pressing, and the whole thing pops out. The piston comes out of these seals and it'll leak oil. So that's how they fail, if you've not set them correctly. So there you go, that's the component parts. So before we move on to bleeding, I'm just going to put the whole thing back together. Try not to damage the rubber seal. You've got to sort of tuck that back in and spin it to get it to engage without deforming the seal. So off camera, I've just carried on doing that until the seal is just inside and the piston goes inside. There you go. So let's put that thrust bearing back on. We'll not bother with the attaching the spring, but we'll show you how to bleed this. Bleeding. So there's some quite simple workshop manual bleeding instructions. You can find these instructions and others on our website, www.modurol.co.uk. But we'll actually run you through this bleeding procedure on our gearbox. So to show you how to bleed, we're going to first put the cylinder back on. You can see already that there's only one input to the cylinder. So there's a small clip we need to use to attach the restrictor. And then there's these 3 bolts, the part numbers I'll share with you, go in. To tighten up those bolts, you'll need an 8mm socket. These need to be torqued up to 9 Newton meters. For the purpose of this, we're just going to nip them up, because we're going to take this off and replace it. This is just to give you an idea of the bleeding. So I've rigged up this setup. Obviously in your vehicle it'll be different, but you've got, on the S-Type, there's only one feed to the slave, but there's actually, the bleed is actually on the end of this, on the end of the, I think it's the restrictor. And what I've done is I've rigged up my pedal box here, and the clutch reservoir is up here, and we're basically, I've got to bleed straight back in, and it'll recirculate as we're bleeding. So we'll just top this up with some brake fluid. Obviously I'm using gloves, so the idea really is we're pumping fluid from the master cylinder through to the slave cylinder, and actually, because this is at an angle, it's actually gravity bleeding. The air shouldn't get trapped because the bleed point is right at the top of the cylinder where the air should collect. I'll just release the bleed. Screw that. Okay, that's loose. And I'll try pumping it. You can see the cylinder moving. Oh, you can see the air there. I don't know if you can see the air. Now push it back and you can see the air coming through the bleed pipe. So pump it right to the end. You don't want to pump it off, as I say, otherwise the thing will just pop off the end. Push it back. I'm intending to prime mine like this before I put it in the car. because it's a bit more tricky. Obviously, when you've got a new one, this will actually be sprung out here all the time, so you'll have to push it back and let the hold it as it pushes forward. Still air coming out. Alright, still get a stream of air bubbles. So eventually, by pumping this, it will release the air from the cylinder. It's taken roughly 3 pedal pumps to get to the end. Because there's no dedicated bleed pipe, it does take longer to bleed this cylinder. Right, I can still see air coming out, but I wonder whether this is a little bit loose. So I'll tighten that up a little bit. I have found it can draw air through the bleed screw. Right, let's try that. So I just tighten that back up now. Okay. So the best way to check you've actually bled it correctly is to make sure it's pushing forward the right amount. So I've just zeroed the caliper there. We'll leave the caliper on and I'll fully stroke the master cylinder. And what have we got then? We've got 12.73 millimeters, or for all you guys in the US, in inches, ½ an inch of travel. So there you go, that's actually working. There's no air in the system. Unfortunately, that in order to get that ½ an inch of travel, I've fully stroked a 1.4 inch master cylinder, which my pedals box isn't designed for. So we need to look at the details of this master cylinder, which is what we'll pick up next. Specification. So the slave cylinder specification is not written down anywhere, so I've actually had to measure this. The maximum stroke of the cylinder is 22.2 millimeters, or 7/8 of an inch. When we've took the slave cylinder apart, we've actually measured the OD and ID of the piston, and we're able to calculate the rough cross-sectional area and also the maximum volume. So the cross-sectional area of this piston is 1.17 cubic inches. The actual heights and strokes, so the overall height of the slave is 68.8 millimeters. After you've taken away the stroke, there's a remaining height of 46.6 millimeters. The stroke of 12.7 millimeters is typical of most clutches being used, and the area of 1.17 cubic inches. The displaced volume, typically at that stroke, is 0.60 cubic inches. Hydraulic ratios. So the hydraulic ratio is the difference in cross-sectional areas between the slave and the master cylinder. So in this case, the slave cylinder cross-sectional area is 777 millimeters squared, and if compared to a 3/4 inch cylinder, that has a cross-sectional area of 285 millimeters squared. If you divide one over the other, it gives you the hydraulic ratio, which in this case is 0.37. If you made the same calculation using a 7/8 of an inch cylinder, a hydraulic ratio of ½ was actually what we were expecting. Okay, there you go. I mean, that's the S-type master cylinder in all its glorious detail. And I think we can start to understand why the system wasn't working quite as expected. Basically because I've designed the system for a 0.5 ratio, but this slave cylinder is 0.37. So the question is, obviously I bought this slave, I didn't buy a 0.5 ratio cylinder. So what options have I got? And that's the subject of our next video, looking at the various options and way forward from this point, either using this cylinder or another. Anyway, hope you're enjoying this video, this series of videos, and our manual conversion project. Obviously, anybody wanting to use this cylinder in any other manual conversion projects, all the details we've gone through, and hopefully that'll help you too. Okay, enough rattling on. Thank you very much for watching. Please like, comment, share and subscribe for more XK videos. Bye-bye.